In this video, we're going to discuss quartiles. And unfortunately, quartiles, the usage of the word quartile is used in two different ways. And so we're looking at basically two definitions. The first one says that quartiles are each of the three data values of an ordered data set that divided into four equal sized groups. So you have to think about that for a minute, right? Imagine, if we're dividing it into four equal sized groups, why is it that we don't have four values to do that, right? So just a quick visual. If you imagine this is a piece of lumber, say a 2x4, and you're asked to divide it into four equal pieces. Well, one way you can do it is say, well, I can split it in half here, and then I can split each of those halves in half. And so I added this, I cut here, right, and I cut here. So that took three cuts, right, 3 cuts to split into 4 sections. And that's why our quartiles are 3 values that actually split our data into 4 equal sized groups. And the way I'm going to approach this is looking at quartiles as just special percentiles. So basically Q1 is the same as the 25th percentile, Q2 is the same as the 50th percentile, and Q3 is the same as the 75th percentile. So that's the first definition that we're going to use. So it's each of 3 data values. So think about it. A quartile is an actual value, right? It's a data value. If you're looking at heights, then each quartile would be a particular height. If you're looking at ages, each of the quartiles would be a particular age, right? That splits the data into 4 equal sized groups. The other way we use the word quartile is this way. 4 groups of data that represent data in the first, second, third, and fourth evenly spaced divisions of a data set. So if I go back to, say, this picture up here, what that means is, let me just change my color here. So what that means is, So in here, all of this in here, we consider the first quartile. All of this in here, we consider to be the second quartile. In here, the third quartile. And in here, the fourth quartile, right? That's where we get the 4. But when I'm going to go back to my blue pen, but this point right here can be considered Q1, right? That's basically denoting the sort of end of Q1. This right here can be Q2, and this right here, Q3. So depending on the context, you have to understand, typically this is what we're doing, right? We're trying to find these 3 values of an ordered data set. And so let's take a look at how we're going to do that. In this example, we're asked for the following 13 shoe sizes, find Q1, Q2, Q3. And so I'm going to translate that into the 25th percentile, the 50th percentile, and the 75th percentile. Now, there are a number of different algorithms for calculating quartiles. You can split it in half, just like I did in that example with the wood. You can split it in half and then split each half in half. When you do that, then you can run into problems like, do I include the endpoint in the half that I'm talking about to figure out the next half? And it gets complicated. And so we're just going to stick to using percentiles. And our process for calculating percentiles is first order the data, smallest to largest. Then calculate I, the index for each quartile, using this formula. So I is the index, K is our percentile, and N is our data size. And then we use our percentile rules. So if this is not familiar to you, then you should look at my other video, which is calculating percentiles. I'm using that same process. So let's do it. So I have the data here, but I'm actually going to take it away. The data here put in order. I meant to do this before. So, okay. So let's imagine I don't have, I'm starting with this data set and I have to put it in order. There are only 13 numbers, so it's not that hard. But I sometimes, to put in order, if I have a big data set, I might build a quick stem and leaf plot just because it's quick, right? So I might say, okay, I'm going to have my lowest here is a 6.5 and 11. So I'm going to use 6, 7, 8, 9, 10, and 11 as my stems. And I'm just going to throw this data in here. So 8, I have 8 is 8.0, I have a 0, then I have a 5. For 10, I have 0.0. So my stem, so my leaves are my 10th places, right? For 9, that's a 0. 6.5, I have a 5. I have a 7, a 9.5, a 9, a 10, another 8, a 7, a 7.5, and an 11.0. And now I could easily put my data by looking at this table. All of these two, notice the leaves are not in order, but there's only 3 of them, so I can do that in my head. So I'm going to start out and put my data in order. So I have 6.5, then I have a 7.0, another 7.0, a 7.5. So I'm just working my way through this table. I have an 8.0, I have an 8.5, an 8.0, a 9.0, another 9.0, a 9.5. I'm going to have to come down here. A 10.0, another 10.0, and an 11.0. So I've put my data, smallest to largest, and now I'm going to calculate I for each quartile. So I'm going to start with Q1. So I'm going to put in a little bit of color here to just help us sort of differentiate what's going on here. So here's my data in order. And I'm going to start with Q1. So for Q1, this is the equivalent of calculating the 25th percentile. So in this case, my K would equal 25. And my N is, there are 13 data points. So I calculate my index using this formula. So it's K over 100 times N plus 1, which would equal K over, so I'm just going to substitute 25 over 100 times 13 plus 1. So this becomes 0.25 times 14, which is, I'm going to do that on my calculator. So 0.25 times 14, and that's 3.5. Because that's not an integer, I'm going to have to go and look at the data. So that I have to look at data in the 3rd and 4th position. So 1, 2, so this is my 3rd position. Actually, I'm going to put the numbers in here. I think that'll make it okay. So I have, so this is my first data point, 6.5. This is my second one. This is my third one, so 7.0. And this is my 4th one. So I have to take the average of those. So my data value is going to be 7.0 plus 7.5 divided by 2. And I'm going to recommend you practice doing these on your calculators, 0.5, and make sure that you get the same value, is 7.25. So that tells me my Q1 is equal to 7.25. So I'm going to put this in blue just to make it really clear. So this says my Q1 is equal to 7.25. Okay, so now let's try doing the 50th percentile. So for my 50th percentile, which is my Q2, this is P sub 50, what do I know? So I know that K is equal to 50 and N is equal to 13. I'm going to substitute in, so for I equals K over 100 times n plus 1. That's going to equal 50 over 100 times 13 plus 1, which equals, let me see. What am I doing here? 0.5 times 14, which equals, so you can do this on your calculator. You might recognize that 0.5 means 50%, which is half. Half of 14 is 7. So I come out with I equals 7. So with an I value, I should put that in here. With an I value of 7, that is an integer, which means my 50th percentile is in the 7th spot. So I'm going to count 4, that's my 5th, my 6th, my 7th. So that's my data value right there. So my Q, I'm going to do this, I want to keep this consistent. So let me just erase this, and we're going to put this in blue. So my Q2 is equal to 7. And I'm going to let you work on finding Q3 on your own, but I will put the answer in here just so that you have it. I'm not going to do it all out. So for Q3, we know that our K is equal to 75 because it's P sub 75. And again, we know our N is 13. If I do my calculation out, I find out that I, our index, is 10.5, which is an integer location. So we actually have to look in the between the 10th and the 11th location, which is 9.5 and 10.0. I average those and I come out with my, I'm going to back to my consistent pen here, Q3 is equal to 9.75. So just a little review of what we just did. I think really the summary is that Q1 maps to the 25th percentile, Q2 maps to the 50th percentile, and Q3 maps to the 75th percentile. And using percentile rules, you can find your quartiles.